In this question, it is given that there is a triangle having vertex at 7, 1, minus 1 and this. You have to find the coordinate of in center of the triangle. Clearly, even if we use the formula for finding the coordinate of in center, it will be too much lengthy to use the formula. To understand the concept I am going to use in this question, I make you understand with the help of this thing. See, suppose a triangle is given to you. And you have to find the area of this triangle. It is clear that finding the area of this triangle in normal way is very lengthy. What trick I am going to use? I am going to use the trick of translation of axis. That is, you must have studied that if I shift the origin to the point say 3, 5 and I get this is the new x axis, this is new y axis, and suppose this is the point 7, 11 according to old x axis y axis. Then according to new x axis y axis, the point will be 4, 6, that is 7 minus 3 and 11 minus 5. That is, if you want to find the new coordinate of a point, then you subtract the point where the origin has been shifted from this point and you get the new x coordinate, y coordinate of that point. And if new x coordinate, y coordinate are known to you and you want to find old, then add these in these two numbers. As you can see very easily that all the x coordinates are near to 247 and all the y coordinates are near to 378. Hence, what I do, I shift the origin to the point 247, 378. It's not necessary that 378, I could take 379 also, but because 378 has come 2 times and 247 has come 2 times, therefore I have used this point. If I shift the origin to this point, the coordinates will change, but we know that by changing the coordinates, area doesn't change, and therefore by shifting of the origin to this point will be 0, 0. This point will be 0, 1, and this point will be 1, 0. And clearly, by taking these points, you can easily find that the area of this will be 1/2. That is the concept is, if this is x-axis, y-axis, this is the point xy according to old x-axis, y-axis, and this is the point hk with respect to old x-axis and y-axis. Now I draw new x-axis, new y-axis, and this is now origin according to these axes. The same point is hk with respect to these axes. And if coordinate of some point are xy according to old x-axis, y-axis, and same point is capital X, capital Y with respect to new x-axis, y-axis. So Just now I told you small x is capital X plus h, small y is capital Y plus k. That is, if some curve is given which has some equation according to old x axis and y axis, say and I want to find the equation of same curve with respect to new x axis y axis, then for x you will be writing capital X plus h, for y you will be writing capital Y plus k. The equation in capital X capital Y will be the equation of same curve with respect to new x axis y axis. And if some equation in capital X capital Y is known to you and you have to get the equation in small x small y, for capital X you will be writing x minus h, for capital Y you will be writing small y minus k. You will be getting the equation in small x and small y, that will be the equation of same curve with respect to old x axis y axis. For more clarity, once again I tell you, suppose this is x axis, y axis, this is the point 7 comma 9. I have to shift the origin to the point 3 4. Then the same point according to new x axis y axis will be 4 comma 5, that is subtracting 3 4 from these. And if new coordinate are known to you, you have to find old coordinate, then add 3 4 to this and you will get the old coordinates. The similar thing I am going to use here also. You can see very easily, if I subtract 3 from x coordinate and 3 from y coordinate from all these points, that is I am shifting the origin to the point 3 3, this point will become 4 minus 2, this point will become minus 4 2, and this point will become 2 root 3 comma 4 root 3. Isn't it? It is a bit easier to deal with these coordinates. And to get back the original coordinates of in center, we'll be adding the point 3 3 to the x coordinate y coordinate of new coordinates. One more thing is also clear, that all the x coordinate and y coordinates are divisible by 2. That is, I'm changing the unit on x axis and y axis. I divide all the x coordinate and y coordinates by 2, and to get back to the original, whatever in center we'll be getting, we'll be multiplying x coordinate y coordinate by 2, and next step will be adding 3 3, and you'll get the coordinate of in center with respect to the given coordinate system. That is, if I divide all the x coordinate y coordinate by 2, this point will become 2 minus 1, minus 2 1, and root 3 comma 2 root 3. To find the coordinate of in center, now we find the length of all the sides. This length will be clearly under 20. This length will be also clearly under 20. This length will also be clearly under 20. Hence, I can say it is a equilateral triangle. In the case of equilateral triangle, centroid, in-center, circumcenter, orthocenter, all are at the same point. X coordinate of centroid is clearly root 3 by 3, and y coordinate of centroid will be 2 root 3 by 3. And now to get back the original x coordinate y coordinate, first we multiply both of them by 2. Note that for coming from here to here, I had divided all of them by this this and this by 2. Hence, first I multiply both of them by 2 and add 3 3 to x coordinate and y coordinate of this point, because try to recall that going from here to here I had subtracted 3 3. Therefore, original x coordinate y coordinate of in center will be 3 plus 2 into root 3 by 3 and 3 plus 4 into root 3 by 3.